So first up, we turn our root x to the 24th into a fractional exponent by turning it into x to the 24 over 2. Remember that the radical, the root, goes on the bottom and the exponent goes on the top. Now in this case then, I can just simplify 24 halves. What is 24 divided by 2? 12. So this simplifies down to just be x to the 12th. Okay, no problem. Use that same idea, please. Go through and simplify the next couple. So then for the second one, we do the same basic process. In this case, it's going to be x to the 24 thirds. And 24 divided by 3 is 8, so that's going to be x to the 8th. Okay, nice and simple. Next one. That becomes x to the 24 over 4. That works out nicely as well. 24 divided by 4 is 6, so this is x to the 6th. Then for our last one, we have x to the 24 fifths, and then this is where things get complicated. And this is really kind of what we're dealing with today, is what happens when this occurs. Because 24 divided by 5 is not a whole number. So what do? Well, I'm going to take the 24 fifths. There's multiple approaches, but I'm going to do it the method where we turn it into a mixed number and look at it that way. So I'm going to take 24 fifths and turn it into a mixed number. So in order to do that, we figure out how many times does 5 go into 24? 4. Goes in 4 times. Because 5 times 4 is 20. Okay, so if that gives us 20, how many are left over? 4. And so it's 4 and 4 fifths. So if I go back to my problem here, that means x to the 24 fifths is the same as x to the 4th times x to the 4 fifths. If you get that little move down, then everything else we do is just going to be variations on that theme. The whole idea is that we're looking to get whatever whole number part we can, and then the fraction is what's left over. Now, in my final answer, I never want to leave a fractional exponent, so I'm going to go one more step here. The x to the 4th, of course, that's what I was trying to get. I leave it as x to the 4th. But then the x to the 4 fifths, I now need to turn that into radical form. So that is going to become the 5th root of x to the 4th. So that then is the final answer, and as simplified as this one can go. It becomes x to the 4th times the 5th root of x to the 4th. And that's why this day's lesson tends to bend brains a little bit. So then I'm going to have you use that information in order to be able to answer these two problems. So go ahead and simplify both of these now. And the whole idea is that you're going to simplify the x's and the y's individually, just like we did when it was just plain old x. All right, so for that first one, I'm going to start by turning both the x and the y's into fractional exponents. So the square root of x to the 12th becomes x to the 12 halves. Y to the 6th, the square root of y to the 6th becomes y to the 6 over 2. And again, it's a square root, that's why they're both over 2 here. Now I simplify both of those fractions. So x to the 12 halves becomes x to the 6. Y to the 6 over 2 becomes y to the 3rd. And that one's done. That's all there is to that one. All right, so now for this second one, we're going to start by doing the cube root of 64, and then we're going to turn the x and y into fractional exponents. Now the cube root of 64, is it a nice pretty number? Well, in order to know, is there a number that we can cube and get 64? And there actually is a nice pretty whole number that cubed equals 64. 4. 4 cubed equals 64, because 4 times 4 is 16, times 4 is 64. So the cube root of 64 just becomes 4. And then the x to the 15th, the cube root of x to the 15th is x to the 15 thirds. And the cube root of y cubed is going to be y to the 3 thirds. Let's go ahead and simplify those fractional exponents. The 4 stays the 4. 15 thirds becomes 5. 3 thirds becomes 1. I don't have to write y to the 1. I can just write it as y. And so then that one is done. All right, now these problems are kind of the butter zone. These problems are the types that I'm going to expect you to be able to leave today doing really, really well. but I want to start pushing your thinking a little bit. We're going to start looking into seeing what happens with some of them that get a little tougher. So we're now going to walk through one more together that is about the toughest that you might see. Because that way, if I can walk you through the toughest that you might see, then you're going to be able to handle the easier ones a little bit more. So start by writing down our next problem. So as we take a look at doing this problem, I'm going to show you some mental math tricks, some little things we can do with formatting that make a problem like this a little bit easier. The more you'll learn these different forms and how they all relate to each other, it gives you ways that you can manipulate expressions like this to make the actual process easier on yourself. One of those things we can do is that since both the top and bottom of this fraction are square rooted, we can actually write this as a single square root. So that's the first thing I'm going to do. I'm going to write this as the 72x to the 13th y to the 6th over the 4x to the 6th, all under the same big square root. What that does for me is it then lets me just simplify the fraction before I have to deal with any of the root stuff. So let's go ahead and do that. So yeah, we are going to simplify this 72/4 first. Now that happens to be a nice pretty number. What is 72 divided by 4? 18. So 72 divided by 4 gives me 18. Then I have x to the 13th divided by x to the 6th. When I divide the x's, I subtract the exponents. So 13 minus 6, that gives me 7, so I got x to the 7th. And then the y on the top, there's no y on the bottom that's going to change it, so the y stays y to the 6th. Notice there is nothing left on the bottom of my fraction. So then there's no more fraction left. All that stuff is now still under the same square root that it was before. So already this is looking a lot simpler than that original problem, right? That original problem, super ugly looking. This is at least simpler. From here, we just have to follow some rules of simplifying, because we can actually simplify each of the three parts that's inside of that radical. And so we're going to deal with each one individually. Let's start with the 18. We're simplifying the square root of 18 like we did a while ago. Today the new thing is the variables. We did the numbers before. In order to simplify the square root of 18, we look for the biggest perfect square that goes into 18. What is the biggest perfect square that multiplies into 18? 9. And so I'm going to turn root 18 into root 9 and root 2, because 9 times 2 is 18. So that takes care of the 18. Now on to the x and the y. For both of those, the first step I'm going to turn into a fractional exponent. So that's going to be x to the 7/2 and y to the 6/2. And both of them are over 2 because it's a square root. Remember, if I don't write a number in the root, it's a 2. All right, next up, we now are going to go through and simplify anything we can along the way here. So like the root 9. That's 3, yeah. So that becomes a 3. The root 2, well, it's just going to stay root 2 because I can't simplify the square root of 2 any more than that. Now the x to the 7/2. This, of all the pieces, is probably going to be the least comfortable. So make sure you really focus in on how we do this. 7/2, just do it kind of off to the side here. 7/2 is a mixed number. How many times does 2 go into 7? 3 times. With how many left over? So then that is 3.5. That means x to the 7/2 is the same as x cubed times x to the 1/2. So I can figure out that I can take out 3 whole numbers out of that 7/2, but it still leaves a half behind. All right, and then the y, thankfully that one ends up being easier because 6 divided by 2 is just 3, so that's going to be y to the 3rd. All right, now I'm going to do one more little intermediate step. You won't necessarily need to write this next step down every single time, but especially as you're learning it, it's good to put it down. The only thing I can check and change at the moment is this x to the 1/2, so I'm going to do that. So the 3 root 2 stays the same. The x cubed stays the same. But x to the 1/2 is rewritten as the square root of x. Because I never want to leave a fractional exponent in my final answer.
Is that how you want us to do it on Llama?
Yep.
Like that is the real order?
Yep. All right, now there's one last thing to do though. And that is actually to get the final answer's order correct. Because I don't want to leave a root 2 sitting in the middle and a root x sitting in the middle. We're going to group the things together that are outside of the square root and the ones that are inside the square root. So outside the square root, I have the 3, I have the x cubed, and I have the y cubed. Inside the square root, I have the 2 and the x.
Okay.
And so then this is the final answer. This is a completely simplified radical.